In this video, I'm going to show you two indeterminate forms and how to use LHospitals Rule. In our previous sections when we studied limits, we could see that we could find the limit of a function by directly substituting the x value in for x. However, sometimes when we did this, it would produce 0 over 0 or infinity over infinity in a rational function. So these special rationals are called indeterminate forms. Now, there are many indeterminate forms, but in this video, I'm just going to show you what to do with 0 over 0 or infinity over infinity. So take a look at these two examples and decide how you would find each limit. So in this first one here, I can see that when I plug in 1 in for the numerator and the denominator for x, I get 0 over 0. So one of the techniques that I had shown you from before is that I can actually factor the numerator to be x minus 1 times x plus 1, all divided by x plus 1, where the x minus 1 is canceled, and then we're left with x plus 1. So then when I plug in 1 for x, I actually will have a limit of 2. In the second example, when I plug in infinity, they're both really large numbers, so I get infinity over infinity. So in this technique, what we're going to do is I'm going to divide the top and the bottom, the numerator and denominator, by x squared. So when I do this, I get 1 minus 1 divided by x squared, all divided by 1 plus 2 over x squared. So in this case, these two terms, as x approaches infinity, they get very, very big in the denominator, so the whole entire term becomes 0. So we have 1 divided by 1, which means that the limit of this is 1. Now, in these two examples, we can factor and reduce, or we can divide and reduce. However, what happens when you get limits like the ones below, where the limit as x approaches 1, we get ln x, or natural log of x, divided by x squared minus 1. So the natural log of 1 is 0, and then 1 squared minus 1 is also 0. When I plug in infinity into the second one, the natural log of infinity is infinity, and infinity squared, also very, very big, is also infinity. So we need to find a different method to evaluate these limits, and this is where LHospitals Rule comes in. So LHospitals Rule is a systematic method. It was discovered by a Swiss mathematician named John Bernoulli, although it was named after a French nobleman, Marquis de l'Hôpital. And it's used to determine indeterminate forms like we just found above. Now, sometimes you will see in textbook that it's also named LHospitals Rule without the S. So here is LHospitals Rule. Suppose that we have the functions f and g, and they're differentiable. G prime of x can't equal 0. On an open interval, I that contains the number a. Suppose also that the limit of f of x is equal to the limit of g of x as x approaches a, and that is equal to 0. Or we have the limit of f of x equals the limit of g of x, but this time, as x approaches a, it equals infinity or negative infinity. Then we have the limit of f of x divided by g of x as x approaches a is equal to the limit of f prime of x divided by g prime of x as x approaches a. If the limit on the right, which is this limit over here, if this right side limit exists, or it equals to infinity or negative infinity. All right, this is a mouthful. So what does this really mean? So this first part here is saying that f and g are differentiable. We know that g prime of x can't equal 0 because otherwise we'd be dividing by 0. And we're approaching some number value a. So in this first part here, it says that the limit of f of x equals the limit of g of x, which equals 0. So that means when I divide, I actually get 0 over 0. This is what this first one's implying. The second part, where f of x and g of x, they're both equal to infinity, this is implying the indeterminate form infinity over infinity. So when we see one of these values, 0 over 0 or infinity over infinity, what we're going to do to find the limit is actually take the derivative of the numerator and the derivative of the denominator separately and then find the limit. So let me show you how to do this step by step. So the first thing we're going to do is we're going to check the limit f of x, whether it is an indeterminate form, 0 over 0, infinity over infinity. If it actually isn't, then we can't apply LHospitals rule. Next, we're going to take the derivative of the numerator and the derivative of the denominator separately. Okay, so this isn't the quotient rule. We're separating them into two parts and we're taking the derivative of each. And then we're going to substitute in the x value. And if you get 0, infinity, or a number, you stop. But if you find that you still get 0 over 0 or infinity over infinity, then you have to go back to step 2 because it's still an indeterminate form. Okay, so remember, if you get 0, infinity, or a number, you stop, you found the limit. So let's take a look at this first example, going through these steps. So let's first check to see if we get one of these indeterminate forms. So this is actually an example from above. So we know that ln, or the natural log of 1, is 0, and 1 squared minus 1 is also 0. So we have the 0, 0 indeterminate form. So we're going to take the derivative of the numerator, and the derivative of natural log of x is 1 over x. And the derivative of x squared minus 1 is 2x. All right, so let's see what happens when we plug in 1 now. So in the numerator, I get 1. In the denominator, I get 2 times 1, which is a half. So I actually found a limit. I can stop now, and we're happy about this. In the second expression, when I plug in infinity into the natural log of infinity, when I plug in infinity into x, I get infinity over infinity. So what we're going to do is we're going to take the derivative, just like we did the first one, and because the function is the same, this is still going to be 1 over x divided by 2x. But this time we're putting in the number infinity. So when I put infinity in the denominator here, 1 over infinity means that I'm going to have 1 over a very large number, which means my numerator will have to be 0. In the denominator, when I plug in infinity, 2 times infinity, a very, very large number, means that my denominator will be infinity. So in this case, 0 divided by any number will always be 0. All right, let's take a look at a couple more. So here we have the limit of x squared minus 4 divided by x minus 2. So when I plug in the number 2, I find that I get 0 over 0. So I can find the derivative of the numerator, which is 2x, derivative of the denominator, which is 1, and when I plug in 2 times 2 is equal to 4. Now note that in this question, I can also do it the other way that we learned right at the very beginning of the year. And that is where we can actually factor the numerator to be x minus 2 times x plus 2 divided by x minus 2. So now I have the limit as x approaches 2, these cancel off, of x plus 2. And notice we still get 4. So I actually find the second way, the one that I've written in green here, a little bit more elegant, where I don't have to just, let's just jump to using LHospitals rule. So it's kind of nicer to do that, if you can see it. Now this last one here is a little bit tricky because it doesn't even look like a rational. So what I'm going to do is I'm going to rewrite it. Notice that there's a little x here times this expression. So this can actually be rewritten as pi over 2 minus arctan x, all divided by 1 over x. Okay, so now when I plug in infinity, we have pi over 2. So remember that arctan of infinity means we're trying to find the angle where we go to infinity, and that occurs at the asymptote, pi over 2. My denominator, I plug in 1 over infinity, I get 0, and then over 0. So this is an indeterminate form. So what I'm going to do is now take the derivative. Now I don't take the derivative of my original question here because that wasn't where the indeterminate form occurred. The indeterminate form is over here where it's 0 over 0. So the derivative of pi over 2 is 0. And the derivative of arctan x is 1 divided by 1 plus x squared, all divided by derivative of 1 over x, number is negative 1 over x squared. All right, so I'm going to spread this out. So this will be negative 1 over 1 plus x squared. So we're supposed to divide by negative 1 over x squared, but let's skip a step and we're going to multiply by negative x squared over 1. So this becomes positive. So we get x squared over 1 plus x squared. And now you have a choice in what method you want to use. You can use LHospitals Rule, or you can divide everything by x squared and simplify it that way. So just because we're practicing LHospitals Rule, let's take the derivative of the numerator to be 2x. Denominator is 2x. And then when I cancel off the x's, 2 over 2, I actually just get 1. So it doesn't matter whether it's going to infinity or not. So just to show you the other way, I can divide all the terms by x squared, so I get 1 in the numerator, 1 over x squared in the first term, and then x squared divided by x squared is also 1. So I'm taking and dividing all the terms by x squared. So I can see that this term will go into 0 because 1 over infinity is 0. So again, here I have 1 as well. All right, and that's it. That's how you can use LHospitals Rule.